Good. So it is 10 a.m. here in France. Well, let us start. I propose that we introduce ourselves first. Paul.
I'm Paul. I'm a software developer for Scilab. So for the software itself, I specialize in XCOS, which is the hybrid simulator. And I also accompany our clients during their application development. And I do training also for Scilab and XCOS.
And hi, my name is Yann, and originally I'm a mechanical engineer, and I joined Scilab for the marketing and business development of the company. And so we are both here in Versailles at our headquarters in France. And well, we're really glad to have you today for this webinar on the subject of scientific and engineering application development with Scilab and Scilab Cloud, which we will present in a few minutes. Without further notice, let us go on with the plan of today's presentation. We will be together for, well, a little bit less than an hour. And, well, you have a chat on your left side. You can ask questions whenever. And I propose that we keep 10 to 15 minutes in the last part in order to exchange questions and answers. The first part of this presentation will be just an introduction in the situation of the engineer today facing the development of application in order to package his know-how in a tool. The second part would be about the solution that Scilab provides.
Just one question. Can everyone confirm that the sound is alright for you guys?
It looks like everyone is answering. So
sound is fine.
Perfect.
Great. Thank you.
So yeah, about the plan, and in the third part we will be taking a typical example of an application with a demo that Paul will perform with a meteorological application with a weather forecast. And in the last part, after that, we'll go through a few use cases, success stories that we've had with industrial users and customers. So let us begin. First of all, so as an introduction, we will take here the simple problem of an engineer who has, let's say, a process to watch a product to develop, and he wants to gather all of the data that comes out of his engineering process. But all of this data, they might need to be used by many applications, by many users from different places. So this is the situation that the engineer is facing today, and what we call application here in this webinar is basically just well, let's say a packaged solution made out of know-how based out of data, algorithm, and graphical user interface. We will go in further detail afterwards. So in order to do so, a bit of overview of the landscape of the solutions that are available out there. It's not exhaustive, it's just an overview, but just to give you also some comparison. So first of all, Excel, because, well, everyone knows Excel and it's been installed pretty much everywhere. So it has the advantage that you can easily import your data, see it through the spreadsheet, show some graphs, and afterwards you might want to distribute it to your colleagues, but then it's actually not the best way to do so, and that's where we're going to show some best practices in the field. It's quite cost efficient because, well, the license, even if it's a proprietary license, it's not as expensive as other solutions. And then the other solution that exists is MATLAB, obviously the proprietary software for computational numerical analysis. So it is actually quite good to develop an application while separating the data from the algorithm and creating a dedicated user interface. It's good to maintain the code because while you have a visibility of readability of the code through a script. And it's actually quite good to distribute. If you own a license of the compiler, you can distribute a subset of your application through a compiled version, which needs to run on a MATLAB runtime. But it's actually really expensive, and that's where Scilab actually comes in the game. So Scilab is an open source software. It is the alternative of MATLAB. It has actually been developed based on the same kernel as MATLAB. And here at the company Scilab, we are developing it further and providing further commercial solution in addition to Scilab. So that's what we're going to present today, Scilab for the development of application and Scilab Cloud for the deployment of this application developed on Scilab. And what are the benefits of Scilab Cloud? It's basically enabling the distribution of a web application with a web interface, which is actually a bit nicer than the one that you can have today on desktop application. And it's a bit more cost efficient in the way that it grows. The cost model is based on the number of users, so it grows with your usage. So these two solutions, Scilab for the application development and Scilab Cloud for the application deployment. I am gonna first introduce Scilab for the development of application. You might know Scilab for your own engineering computation. If you're an engineer and you want to do some data analysis, you want to make some post-processing of data from test and measurement, for example, or you want to build up a model based off a differential equation. There's a lot of application field where you can use Scilab in statistics, in optimization, signal processing, and control system. Here, in this hour, we're going to focus on the part where you have your algorithm based on some data, and you want to package all of this know-how in an application. So this is how you're going to do it. You're just going to have your data sets. On the one side, your algorithm written in a script with several functions, and after that, developing a dedicated user interface still in Scilab. So you get function within Scilab in order to develop your own user interface for your end user, and Paul is going to display that later. And in addition to that, if you want also to add up some legacy code, some code that you've already been written in C, in C++, or in Java, you can also add it to your application with the same user interface through the Scilab API. So this is something that we're not going to develop so much in detail, but if you have questions afterwards, we can add some information to that. So this was for the development of application based on Scilab, so this is completely open source and free. You can download it and try it out yourself. And in the second time, let's say now you want to distribute this application to your colleagues. What we want to present today is the way to deploy application directly through a web browser. So this is quite new. It's we've been developing it for the past 6 months here at Scilab, and we're introducing this first feature, this first product of the Scilab Cloud suite. So what is Scilab Cloud? At the moment, it's Scilab Cloud app is meant for this deployment of web app with a user interface or without a user interface through an API, a web API. Here we're going to concentrate on web app, so meaning interface with algorithm. And this cloud is actually Well, it is a Scilab version based on a server, on a private or public cloud, meaning that well, you can either directly send your application to our Scilab Cloud online, or you can have within your company an installation, dedicated installation of this Scilab Cloud on a private server. And for the public cloud, we are partnering with some big players in the field, like Google Cloud, Microsoft Azure, or Amazon Web Services. And well, what it does is it's actually just rendering the application, the interface of the application within the web browser, and working with any current web browser such as Mozilla Firefox or Google Chrome. So this is it for just a global presentation. In order for you to have a better impression of what it does, I propose that we go directly to the demonstration that Paul will perform of a weather forecasting application. And here in the print screen you've got the end result of the web app, but in order to go all the way, we're going to take it step by step from A to Z in order to show you how we can develop and deploy an application with Scilab and Scilab Cloud.
Yes, I'm going to take it on from now. So I'm going to share my screen. And you guys can use again the Fit to Screen button at the bottom right.
You can also display it in full screen in order to see.
Yeah, if the font is too small, you may use the full screen feature. Okay, I have. So we chose weather forecast application in order to show that the whole life cycle of some data. So from where it has been picked up, like on a weather station where measures are taken. All the way to that they are transferred to an engineer that's going to process them, maybe have some visualizations from them, or to an even further user after that. So this is the classical Scilab environment. So on the left, I have my file browser. Here I see that I have some CSV files that have been transferred to me from the station. In the middle, on the top corner, I have my a small algorithm that's just gonna extract a value from my data and do a linear regression on it and display the results. So this is my small algorithm. On the right, I have my variable navigator, which is going to keep track of everything present in my Scilab environment. And here is my console in which I'm going to send the instructions. So first, I'm going to read, import into Scilab my CSV file, which is there. For instance, I'm going to take the Orly station. So when I do that with CSV read, which allows you to import CSV files easily in Scilab, I see that I have created an A variable, which is an array, a matrix with 12 columns. If I double click on it, I see that I can display my values, just like a tabular, an Excel tabular, something like that. And I can go through the different columns, which are, each of them is a different unit. Here I'm gonna, here I'm gonna focus on the pressure. There it is. This is the pressure values that have been picked up by the weather station, and I can easily plot them in one click. This is what I get. So during a whole year, this is the pressure variation. And now I want to apply linear regression to that trend. I don't need this anymore. So I want to run my small algorithm on my variable a. So I'm just going to play that script with a play button. And this shows me the visualization that I have earlier with you can recognize the pressure and the linear regression on it. Here, the first order regression. And now that I have an algorithm, I want to have a small interface which allows me to mock my code, so to have it with just one click instead of seeing it. So I want to take the user point of view instead of the developer point of view. This is easily done in Scilab in a few lines with a small script, which I call interface. If I run it, so you see that I'm just creating a button with it. If I run it, I have my small interface. Here you can see it better, which I could have even taken it down to one button. Here I chose not to hide the menus, but I could have. So this all comes down to one button, which if I click on it, runs my small algorithm. So I get my linear regression and my visualization. So this is neat. In a few lines in Scilab, you can have a small, very basic interface. Now what I want to do is to strengthen my interface to have a whole application, so with all the regular features of an application. This is what we have done I was here in the data folder, and now I'm going to run my whole interface. This is what it looks like. So it's an example of a weather forecast application. I have pop-up menus which I can scroll down in. I'm going to import the data just like I did on a command line, but it is done automatically for me. So once my data is imported, I can focus on different columns of A, displaying different units. I can apply my regression on a different period of time, so it's adaptable, and it changes the regression. For each unit, I'm gonna validate a trend, so it's gonna take into account the regression here. So for the 3 units, for each of the 3 units, I validate a trend. You see here that when I do validate a trend, there is a small mark here that shows that it has been validated. Same for the wind velocity. Now that I have my 3 trends, I can predict a weather forecast, a future weather, and the whole application comes down to, the results comes down to one sentence, showing here non-stable weather with extended period of precipitation. So that's it takes in the 3 regressions, and it tries to predict what it's going to look like afterwards, after the period that I have selected. And I can do it yet again with a different period of times and different weather stations as well. So this is what we call the application. It's the user interface. Now what I want to do, this is in local, so that's a desktop application. It's just for me. It has been maybe developed by me, and it's on my machine, but it's not on a colleague's machine. So what I want to do now is to distribute my application to my colleagues or my end line users. And I'm going to do that through Scilab Cloud, which is the new solution. And I'm going to pass it on back to Yann, who's going to show you the web interface of Scilab Cloud.
So yeah, you can come back to my screen sharing, and well, I'm gonna introduce you to. Maybe you want to stop your screen sharing.
Stop sharing.
Okay, so back to my screen. Now what you see here is a website Scilab.cloud. It is live. It's not publicly available. I mean, you cannot create an account yet. Meaning, I mean, for that you have to have a commercial contract with us for your enterprise distribution of an application. But I'm going to go through just a feature of what it does for you to have a glimpse of Scilab Cloud for the deployment of web application. So here I'm registering as an administrator, and on this dashboard I have a few applications available here, especially the weather forecast application. I won't go directly to it. First of all, I will just show you around a bit the settings, especially of this application. So here, as an administrator, I have this user profile with all of my personal information, but also, in addition to that, since I am the administrator of this application, I have user management, group management, and application management. So for this webinar, I'm just going to delete Paul and create a new account for him once again. You're going to see how it goes. It's actually quite straightforward. I'm just going to enter his email address, and I am going to allow him to have access to this application weather and to this both weather station, Ajaccio and Bastia. Let's say for this example, Paul comes from Corsica, and well, he's gonna take care of these two stations, and he's just gonna have access to the data of Ajaccio and Bastia. So here you're gonna see how through this group management we are enabling also this data management for different users. So here you go. I just created Paul, and I'm gonna hand it over to him so that he can show you from his user perspective. So here I was just the administrator of this application. He will be the user, and we're gonna go back to his screen so that he can see after receiving an email from Scilab Cloud how he's gonna register and access the application.
Okay, I'm sharing my screen again. Just a second. There you go. There. Okay, so I just received an email from Yann asking me to join the Scilab Cloud, and I am creating a password, checking that I'm no robot, and then I can log in. Ben non, j'ai mis à jour hier.
Okay.
Yes. Okay, so now I'm logged in as a user, and I see that I only have access to the weather application, which Yann gave me access to. And my settings are different from him, of course, from his. If I click on them, this is the only things I get. So if I don't like my name, I can change it. Or I can change my password. Or in the groups and access, I can see that I have access to the following application in the Scilab group. And access to Ajaccio and Bastia people group, so only to these data. I also have a data management tab that lets me see the available resource for the groups. Now, back to the application, what does it look like? So if I launch it, right now the server is starting the Scilab and giving me and launching the application inside that Scilab and giving me control over it. So here I recognize the application that I had earlier in Scilab. I'm gonna alt tab to it so you can see pretty much the difference. There is a slight rendering difference because we're not based on the same rendering libraries, but the code is the same. There is no change in the code. See that it's slightly different, but not so much. And still the features are the same. So I can import my my data, analyze it. That's gonna prompt me to execute the regression on each unit. And every time I validate a trend, there's an indicator here that shows me that it's been validated.
Yeah, there's a slight difference in the code just for this visual indication. They are basically the only difference between the desktop and the web application version.
Now that I have validated my 3D trends, I can predict my forecast just like before, and I get the same results. So my whole sentence based on the 3 regressions. Here you see that you have some kind of neat feature for that graphical library, which lets you roam around, and when you hover around the point with your mouse, it shows you its coordinates for all of the different curves that you have in your graph.
You can also zoom in.
I can zoom in by
the window.
I can zoom on a certain area of the graph. Yeah, like this. Zoom in again on another area, and if I double click, it's going to zoom back out.
There's a bit of lag with Bignier, but it's actually quite. I mean,
it's very responsive.
It's really responsive, and what it does is actually going back and forward to the Scilab connected to this web interface. So it's a live processing of the data.
Okay. Now I'm gonna hand it over back to Yann again.
So here, what we saw was the presentation of a user. Let's say someone who's handling the data from a weather station. And here I'm going to take another example of an administrator which would be centrally handling all of the data. And as in the introduction, this is another user. He has different rights over the different groups, and well, he has also another application based on the same data. So what I'm going to show you now is another application based on the same data, which is called Dashboard. Here you see it's actually a different visualization of the same data, but also from different groups, because here I have access to all of the groups, not only Ajaccio and Bastia, but also Orly and Toulouse, as you can see. And I have a different visualization of the same data. Here, for the temperature, the pressure, and the wind velocity, I have a minimum, a maximum, and mean value displayed as a bar chart. I have also another tab here with the temperature and the dew point of the temperature for Orly, Toulouse, and Ajaccio on time baseline, and also a pie chart of the humidity for for all of the 3 stations. So this was another example of the different views that you can have, enabling, well, to collaborate on the same data, which are centralized on a server. Here you don't see the code of the application. It is also hosted on the server centrally, so the user don't have access to the code. It gives you the benefit of keeping your intellectual property. also keeping the application, integrity of the application, so that the user cannot change the code of the application and get wrong results. You have complete control over the application on the complete lifetime of the application. And well, you can also get back the results of your different users, so that you can also have a good management of your project over the time. So after this small demo, we're gonna go back to the presentation and show you now a few examples of industrial use cases leveraging this application development capabilities of Scilab. Here you have just a few use cases, but you can go on scilab.io to see further example of industrial use cases. And we're going to start by the one of Airbus Defence and Space. In France, they were developing the launcher of the rocket Ariane 6, and in order to do so, they were working in the precising department of Airbus Defence and Space on mechanical precising. For that, they developed a small application called Scilab, and it's basically doing a buckling computation using algorithm from scene element theory, and they implemented it all in this application that they are using internally in this small group of 10 persons. Another example in the field of aeronautic is from Dassault Aviation. And what they are doing with Scilab and with this small application is the optimization of the aircraft design. They gather data both from the test and measurement, but also from different simulation, from finite element analysis, and for mechanical structure, but also for fluid dynamic. So all of these points are actually results either from test or from simulation. And what they want to do is to perform a design of experiments in order to assess the impact of several parameters on the output of the considered design. They perform machine learning algorithm and optimization directly thanks to the capabilities of Scilab, and they packaged it in a small application used also in this development group. And the last example, now both of the examples before were desktop application, and now we have already a client for the use of Scilab Cloud for a web application deployment. This is Sanofi, a big pharmaceutical company, and what they want to do is to optimize the consumption of their energy on air conditioning. They saw that there's a big benefit in doing so by running a project on a pilot unit in France. On this unit, they had €500,000 of cost in energy, and 50 to 60% is due to air conditioning. So they thought if we have a better control strategy over our air conditioning, we can win between 7 and 10%. And well, for just one site, it might not be significant, but for the whole company, for the whole group of Sanofi, over the 120 factories that they have worldwide, they think that they can have a quite significant benefit of more than 15 million. So it would be the cost of one factory for them. So they thought that it would be great to have a better strategy for optimization of their energy consumption. This was the purpose of this application, and after developing a desktop application, they figured that it would be much easier for them to follow the project with a web application in order to centralize the data and have a deployment of the application without having to install on every workstation a heavy client software. For the IT, it's much easier, and while it goes much faster, they have the control over the whole project, and they can meet their objective of cost reduction. So this was the three examples that we wanted to take in order to show you a bit of the potential of these capabilities of Scilab for application development. As a company, what we do is basically we provide services in order for you to get started, to develop your own application. If you have an idea, maybe you want to get back to us and see how we can work together, either by giving you trainings, or we can also, what we do with several clients is doing outsourcing of the development of these applications. And in the second time, as soon as you have an application running, well, feel free to contact us in order to deploy it on the Scilab Cloud, and we'll be glad to have a further application to display in the next webinars. Thank you very much. We have a few minutes for question and answers, and here you feel free to ask your question on the chat. We are still here for a few minutes in order to answer your question.
Yeah, Webico even lets us continue after the 45 time mark. So we are here. It's a pleasure for us, like we said, to be in direct contact with you. So please enjoy the time that we have and ask all your questions.
And we were recording this webinar, so you will have a link to the video on YouTube in order to visualize it and share it to your colleagues later. I'll send you an email here. You have my contact detail, but I'll send you also a direct email so that you can get back to us, and I'll be glad to exchange with you about your ideas on application, on what you do with Scilab. Maybe you have further use of Scilab for development.
Tobias, hi to welcome to Scilab. The major difference, of course, is that Scilab is an interpreted language and Fortran is compiled. But on the developer point of view, it's Scilab is based on some Fortran, C++, C, Java libraries. So basically, you can view Scilab as an overlay of all those libraries, like compiled language libraries. So if you call Scilab, it's easier because it's not as typed as Fortran, but you can it calls Fortran behind. So basically, it's an overlay of Fortran, and you can easily inside Scilab you can easily link. At least you can link your Fortran code directly. So if, let's say I have a Fortran code which takes a few lines, I can easily link it with Scilab and call it from Scilab. That's something you can do in Scilab. There are, if you want to go check in the demos, Scilab demos, in a dynamic link, there is an example of that. C and Fortran code linked directly to Scilab.
And I think from the user perspective also, I mean, Scilab is a language, but it is also a software coming with a lot of feature and a lot of libraries for scientific computation. So from a user's perspective, when you are an engineer or scientist, it's actually much easier to address your problem, and most of the time more straightforward to do so with a scripting language as Scilab, coming with a lot of libraries in mathematics, in applied mathematics, so that you don't have to implement all of your code. For example, just in signal processing FFT, a Fourier transformation, you don't have to implement it. There's already a function for it in Scilab, within Scilab, with examples. So Scilab comes, as you saw, with a lot of feature for the development of scientific applications.
There's a question for you. That's
can we develop a machine learning application using Scilab? It's a good question. We've been actually for the past few months working on this subject. You will find on scilab.io a few examples, a few tutorials on how to use Scilab for machine learning. Scilab is actually quite good for that, just like MATLAB, because first of all, because of the scripting language close to the mathematical field, and machine learning is actually a lot of mathematics and statistics. So with the scripting language of Scilab, you get good capabilities in order to develop your algorithm of machine learning. You've got also a lot of functions that comes together with Scilab in optimization, and since machine learning is a lot of fitting of models, well, you need to have a good optimization function in order to fit your data to your model. You can do either classification or regression problems, and so a lot of function for regression already comes together with Scilab, and in classification you can implement logistic regression. You can also link Scilab to toolboxes, additional toolboxes such as the SVM toolbox for support vector machines. So these are really advanced capabilities in machine learning, and there are also new toolboxes in neural networks. So, well, I'm not going to go all over through the subject. It might be another deep subject, but yes, definitely you can do that with Scilab.
Stefan, to answer your question, yeah, you're welcome. To answer your question, I think if I were to do that, I would mix the documentation, so the help pages, with the already present user interfaces inside Scilab. So what I'm thinking about is the demos again. So if you open the demos in Scilab, there is the small wheel at the in the menu bar, which opens the demonstrations. You have a graphical interface section that shows you Scilab's capabilities, and you can use you can view the code. Of course, it's open source, so you can view the code and start from there. Use that. There are several different interfaces, and you can pick which components you want in order to make yours. But no, you can start as a canvas from that to build your own, because it's we did it, so it's good practice coding. And with the documentation aside, with some more textual information, you'd probably reach your goal.
Yeah, it's actually the best way to do so, and we actually also wrote a tutorial on Scilab.io based on this demo of one of the graphical user interface. So on the front page of Scilab.io, you will find also a tutorial based on this of this demo. So this is actually is the best way to do so.
Anything else? Any information that we would like to? As you saw in the slides, the Scilab Cloud is available on Internet Explorer, Firefox, and Google Chrome. So we don't have cross browser problems, and it's based on the latest technologies such as HTML5, CSS3, and JS5, I guess.
So yeah, if you need more information concerning Scilab Cloud for the deployment of enterprise-wide deployment of application, at the moment what we focus on is this enterprise deployment of applications. So we have an enterprise solution. and well, please contact us if you want to leverage that.
Yeah, the point that we wanted to make also is that we can be present with you the whole way. We can help you develop your application if it's not already developed or optimized, and we can as well be present in the deployment in local or public deployment.
Well, if there are no further questions, well, thank you all for participating, and I think we'll close this webinar on these few words. Once again, do not hesitate to send us an email, and well, we were glad to have you today. Hope you enjoyed it, and well, keep posted for the next webinars.
Yeah, like Yann said, we'll be sending a follow-up email linking you to the YouTube post, and as well we have the same webinar at 5 p.m. Paris time, so in 7 hours, 6 now, in English as well, to cover different time zones. So if you have colleagues that might be interested, you might link them to it.
Thank you all, and bye bye.
Have a good day. Have a good night, whichever works for you.
Bye.